Thanks, Garrett. It's a real pleasure to be here. Thanks, everyone, for coming. Great. Yeah, this worked out to be a nice time to give this talk because we're midway through, a little more than midway through the project, and just coming out with our first real detailed analyses of the delta landscape, how it's changed through time, the delta landscape method, and we'll be coming out. Sorry, what happened?
Continue.
Continue? Okay. So it's good timing. A lot of stuff you'll see is really hot off the press, and it is from our forthcoming report that should be out in early October, sometime in October, just in time for the science conference.
Can you guys offer to share with me again?
Okay.
There I bragged about slaying the WebEx in America. Hang on things. Totally. That's okay. It gives us a little moment of humility and time to talk. Let's see if that works. You all see it, but it's the people out in WebEx land that aren't seeing it, I don't think.
Right.
But we'll just continue.
Okay. So, I think many of us are working on this challenge of how do we really do ecosystem restoration in the Delta. It's a tough assignment given the incredible transformation of the system over the past 100 years. It's almost unrecognizable, and yet we're trying to create ecosystems, functional landscapes. And many of us wrestling with the challenge of how do we make relatively small projects add up to functional systems over time. So the Delta Landscapes Project, which is funded by the Ecosystem Restoration Program through California Department of Fish and Wildlife, is attempting to provide some of the tools to help us address that challenge. We're trying to accomplish a few different things, providing a framework that helps individual projects add up to a larger functional landscape.
One more try. If you're someone,
should I keep going or should I?
If you'd like. Let's see here. Let's try
if
one
I can
more
remember
time.
totally.
Even on there.
Yeah. Here. Now try it.
Okay.
Now do you see it? Okay. Let's see.
I had a talk at UC Berkeley recently that the time was wrong, so nobody was there when I got there. Then the power went out partway through.
Seems about the same.
And then the fire alarm went off at the end, and we all had to leave.
This is minor.
This is nothing. So, yeah, what's the puzzle? What's the picture on the back of the puzzle that we're trying to aim for with the different pieces we have? Second, provide some guidance as to what kinds of projects make sense where. I think we're aware of the tendency to maybe have one-size-fits-all projects, but the Delta is a really heterogeneous landscape then and now. Hopefully reduce conflicts and mistakes by having this broader perspective. Make better use of the long-term physical and climatic trajectories by understanding the physical settings which exist and still exist in different parts of the Delta, and facilitate projects that are really working within that context, which often involves probably multiple projects at a bigger scale. Am I close enough to this microphone for folks in the back? Okay, great. And also be thinking about the sort of larger ecological world. How do species move from different parts of the Delta? How do they migrate? How do they adapt over time as conditions change? So those are large challenges that many people are working on entire programs. So we're not trying to answer all of those, but hopefully provide some tools that move the bar, move us along a few steps in that direction. Basic concept of the project, as Garrett said, building on the understanding we now have of how the Delta could or should work under more natural conditions, understanding of that process and pattern, that the physical parameters that created the habitats that provided functions. Understand that better now. Let's try to use that in the context of landscape ecology, conservation biology, and physical analyses of the contemporary landscape to figure out what we could do to make functional landscapes. So what do we mean by functional landscape? Well, we pulled this out of the literature from some Dutch scientists. The idea that you need to figure out what your target ecological functions are, whether that be salmon rearing or productivity or what have you, right, bird habitat. And then you assess what the physical drivers are that you need to really create and maintain those habitats at scale, over time, through climatic variability. And that leads you to a operational landscape unit. And that would be sort of forcing in maybe the historical, like the way the system used to work into the contemporary limitations. So how can we create at least somewhat functional mini versions of deltaic processes within the contemporary delta? That's the basic idea. And that those could be guided and shaped by and quantified and sort of tracked by landscape scale metrics that would help you assess whether you actually are creating those operational landscapes, functional landscapes. So this, what I'll present here, is the step of developing those metrics. And then those would help influence the conceptual, that's the wrong button, help influence the conceptual design for restoration projects early on so that we'd those would be conceived of in a broader context, et cetera, et cetera. And then those would be tested over time through research and adapted, et cetera, et cetera. So this is building off the historical ecology study, which gave us, kind of a nice, relatively unmanipulated system to look at how it works and how it provided different functions in different physical settings. And now we're doing the challenging work of saying, okay, well, what does that mean when processed through the lenses of landscape ecology and geomorphology and hydrology? By the way, we have more copies of that report available now, finally. And so let me know if you need a copy. Thanks to Swifka, who printed a bunch. So the here's our basic kind of a simplified approach of how Delta Landscapes Project proceeds. We start by defining the target ecological functions. Those would be, as I mentioned, some of the functions we care about among native species in the Delta, in the past and present. And then we identify what are some of the things we can measure in the landscape that, based on all the science and professional judgment we have, actually support those functions. So that might be like, for salmon rearing, terminal or dead-end tidal sloughs, or for birds, for certain riparian birds, riparian forests of a certain width. So those kind of metrics. And then we quantify those, past and present, actually analyze how the patterns have changed over time. And so these are, of course, somewhat of an approximation of how the ecosystem, the complex ecosystem, actually works, right? Ecosystems are extremely complex, and we can't necessarily measure every attribute that we might want to. But these are attempts to be things that you actually can measure and track over time that are identifiable through aerial photography or mapping, and actually should have ecosystem-level attributes and functions. So that's the part that I'm going to talk about today, this area. And then this is where we're headed in the next year of the project. A key part of this project is that we have our scientists at SFDI, and then many of our colleagues we're kind of bouncing ideas off of constantly, many of whom are here in the room. And then we have a really talented team of science advisors. We call them the landscape interpretation team because they're not really just advisors, they're actually fairly involved in helping us think through what we're doing and what things we should measure and why and what it means. So, and it's purposely an interesting combination of ecologists, very talented ecologists, a lot of expertise, and also physical processes folks. Just trying to have those people in the same room through the entire course of the project. And they've been extremely helpful. I see Dave Zezelak is here, one of them, and Chris Enright in the audience, maybe anyone else. So we really appreciate their engagement. So I'm not going to get into all the details, and the ecology side is led largely by Letitia Grenier, who you may know of, who's also leading the Bayland Goals Project. But we're trying to think fairly broadly about ecology, not just listed species and very specific functions, but some of the broader needs for ecosystems to persevere over time and populations. At the population level, the ability to evolve, continue evolving over time and adapting, food supply. So both some of the classic things like what do you need for pelagic fish, and but also some of the broader concerns about genetic and phenotypic variability, those kinds of things. So we're trying to have this be fairly broad in concept. I don't know, we can look at, for example, all the BDCP species to see how they fit, how they utilize the different habitat types that we're able to map in the past and present. And then we've, through long sets of presentations and debates and follow-up meetings, come up with a fairly focused set of landscape metrics, of functions that we're actually trying to map in the past, present, and ultimately future delta landscape. This is maybe slightly out of date, so they may have evolved a little bit, but this gives you an idea of kind of the diversity of kinds of functions we're trying to quantify. And then we take those, you remember those symbols, and then we have metrics, one or more metrics associated with each of them. The things like velocity,
you can tell just from listening, but
that's kind of the basic idea. That leads us to these classic landscape ecology metrics, but they're based on specific care about. So today I'm just going to focus on a few of them, and we hope you can have some time to give you a little taste of them. What they're looking like. So,
can people on the phone mute? We have a lot of background chatter, please. Thank you.
Hi, Stuart.
Hi, someone's not muted. It's a little challenging. Thanks.
Have a good afternoon. Thanks.
I'll send you the link.
Yeah,
so 4 categories: marsh wildlife, native fish, riparian wildlife, and edge wildlife. Although last night, as I realized I thought the talk was too long, I'm afraid I dropped out the edge wildlife part. So that'll see that in another presentation. So focusing on support functions for these 3 categories in particular. And here's the metrics we're going to go through, the landscape metrics: marsh patch size, marsh to open water ratio, length of marsh water edge, inundated areas. So that's a sort of subset, but to give you a feel and a flavor for what this information is, how we might start thinking about using it. So first one, kind of maybe one of the more basic things to consider about the delta is its transformation from large wetlands to tiny wetlands. So support for marsh wildlife, so that is considering, we don't always think about it in the delta because of the concerns about fish, but all the species that depend on marshes themselves, such as rails, shrews, tricolored blackbirds, et cetera, et cetera. There's quite a number of species dependent on the wetland, the tidal marsh system, freshwater tidal marsh systems themselves. That landscape has changed, as you might expect, quite dramatically. Now here you have to choose a patch size, and patch size can be different, would be different for every species of concern, right? So in this case, we've used rails, black rails, as a species to choose because they have a relatively large area requirement to get their to hit kind of most optimal habitat, and that probably accounts for many other species that have smaller ranges within that. So you want to choose something relatively broad. And that's actually a species for which there's some good data. So taking rails as a metric, you can see that, I'll get to that in a second. Taking these patch sizes, you can see that historically, as you might expect,
Bye, Robin.
most has raised a hand. Wow. I saw that button yesterday. I haven't used it. Yes, Stuart? Is that actually like
a question? There's someone's got a whole separate thing going in the background, and all we hear is someone's side conversation.
Really?
I'm hoping they can hit mute or do something.
Huh.
So I'm just.
Did everyone hear that on the call? That there's some other conversation going on that's distracting and
yes,
probably
very much so. Yes.
Yes.
So yeah, everyone could go on mute unless they have a question. Okay, I guess I need. Is that any better, Stuart?
So far, so good, but it was intermittent, so let's hope it sticks.
I think they hung up.
Okay. Okay. Great.
Okay.
So here we've separated out into sort of by orders of magnitude, different patch sizes, and the quantified that past and present. You can see historically, as you might expect, but it's still quite impressive and somewhat surprising. Almost all of the area was in extremely large patches, 10,000 hectares or greater, a little bit in the 1,000, very few in the smaller patch sizes, where all of that area is now. Essentially all of the areas in these smaller classes. And so these are, by the way, these aren't just polygons, random polygons based on digitizing. These are actually assembled based on rules for rails, how much, what a barrier is, how much they can cover in between patches. So then we could look at that and we can say, well, these are, provide some support, but optimal habitat is actually in this range. As you can see, we have very little habitat in this at the level that would be needed to really sustain these populations over time. That's based on research by Hildy Spotts and a number of folks associated with PRBO. And you can see that using that metric, historically there was 192,000 hectares that was large enough to fully support rails. This is, of course, only one element of the life cycle. This is one metric. And today there's only 1,000, so a fairly dramatic decline. You can start to maybe envision how we might be able to use some of these as targets, and so we can evaluate, are we getting towards some of those patches in the future. We're also, since this data is new, these data are new, we're exploring how to present some of this. So this is another kind of fun way to look at it. Maybe. Some people love these tree diagrams, some people seem to hate them. But these are tree diagrams. And so each of these squares represents a patch. So every patch in the delta, past and present, is represented here. Historically, you see these big ones. All these little subdivisions are individual patches over here on the modern side. So historically, there was one large, as Sam Saffron here, my colleague at SFI, who made this, called it the Central Delta, South and Central Delta Mega Patch. It was 110,000 hectares in size, which is on the order of 250,000 acres in size, one patch. So fairly mind-boggling. Think of the size of that. The biggest one today is Sherman Island, 749 hectares. 749 versus 250,000. Well, 749 versus 110,000. And correspondingly, there's actually a lot of patches in the contemporary delta, 1,200 patches. We only had 43, so we're doing great in terms of number of patches of marsh. Just exceptionally overachieving. Of course, that means that the average patch size is 4 hectares, whereas it was 4,000 hectares. That's a fairly remarkable decline. When you think about, we always talk about 90% this, 90% loss of that. This is not 90%, this is 1,000-fold. This is 99.9. So that gives a sense that I hadn't even realized doing the whole oral historical ecology report of the extent of transformation. As I take it a step further, this patch right here, the 6th largest patch, is bigger than all of the marshes today, which of course are fragmented. So we're going to kind of work our way through the ecosystem or through the landscape. So that was the marsh, and now the other kind of big piece is the open water, which you kind of think in the most simplistic terms. So open water, the aquatic and explicitly aquatic area, unvegetated, has actually increased pretty dramatically from 16,000 to 27,000 hectares. Pretty big increase. At the same time that marsh has decreased by 98%. So one of the things that LIT, the Landscape Interpretation Team, was interested in was this idea of the relationship between the two. And so we can show those, the ratio. Historically, the ratio was basically 100 to 1,000, or 10 to 1. It was 10 times as much marsh as open water. And now it's almost the reverse. There's like 6 or 7 times as much open water as marsh. So you can think of it as the pie has gotten smaller. So the pie of tidal or available habitat area for native species has gotten smaller by about 7-fold. That pie is much smaller. And then the pie is just a different flavor of pie, too. It's gone from being a marsh pie to a water pie. A marsh pie with like a little bit of I don't know, sprinkles or like cherries on top that are water. And not to carry this metaphor too absurdly far, but that's a marsh pie with a little bit of water in it, and this is a water pie with a little bit of marsh in it. This might have been a little too late last night. And so think about it another way. All of the water that was in the delta historically really was part of a tidal marsh, right? It was a tidal marsh channel or pond, whereas today you really have little bits of marsh existing in channels in an aquatic system. So it really is this interesting reversal or inside out or something of a landscape. It's completely transformed, and then trying to support native species in that. Very interesting situation. And of course, this is somewhat hotly debated and discussed, is what effect those marshes had on the open water. Back in the envelope calculations suggest that even if a very tiny percentage of the productivity of the marsh system got into the open water ecosystem, even just at a 1%, it's a pretty huge number. But that hasn't really been evaluated, fully vetted. There's actually a sort of companion project starting to take shape with a number of scientists to actually evaluate those changes in productivity past and present using these data and other data. So what you can see, we're starting to get a sense of the basic ways of thinking about this transformation, quantifying it. So the next step is that for any aquatic species to make use of whatever the marsh is providing, whether it be cover at the edge or shading or a food subsidy, that all happens at the edge, right? And so we were asked to analyze the amount of open water to marsh edge. You know, this is where biology and chemistry happen, sort of the interface. So we quantified that, and that's what this purple is. You can see the diagram up here. If this is open water and these are patches of marsh of different size, the purple is where they interface. And so to some extent, it's kind of impressive. There's quite a bit of interface left, although it's still not anywhere near as much as there used to be. And if you take a step to think about the fragmentation that we showed earlier, 1,000 times smaller patches, but many more patches, kind of amazing that the interface, that edge has still decreased so much. Because fragmentation tends to increase edge, you know, multiply it out exponentially. This is really a dramatic loss when you acknowledge how much edge comes sort of surprisingly here in the center. And so this led the team, us and the advisory team, to say, well, yeah, that's not exactly what we're trying to get at. You know, we're interested in a lot of this is edge between tiny little bits of water and tiny little bits of marsh. That's not really necessarily a productive metric we're looking for. And so this leads to an interesting thing, which is many of these metrics aren't that useful in and of themselves. They need to be layered on top of each other. And so what's interesting is the edge associated with different patch sizes, right? Because you could just get tons of edge if we took every marsh and turned it into little tiny pieces, which we've already done. So if you look at it this way, now we're breaking it into big, medium, and small size of marshes. And in fact, the big is not very big here. It's a modest bar here of 100 hectares. But if you break it up that way, then you see that we have a lot. We had most of the marsh edge was next to very large polygons historically, whereas now the edge that we have is next to tiny little patches. So that points out we wouldn't actually expect it to do much, if anything. So we're not getting the we're not fulfilling this metric if we think this is something of importance. In fact, let's take it a step further. It might be kind of like the pie. So the edge length has gone down, but the length of this channel, this edge, I found fairly remarkable. So you had 2,800, I think, kilometers of edge next to giant marsh patches historically, all the way to Cleveland. You could go as a fish in the delta and you would be next to giant marshes. Whatever they do, you'd be in that vicinity. Today, you could get to Roseville. It was 19 point something kilometers. So again, just in terms of what fish are looking for, they're definitely seeing different things now. This is one way to think about that. Okay, now the edge, that's kind of thinking in the delta as a simplistic two-dimensional landscape, which is really not the whole point of a delta. The point of a delta actually probably is more the flooding of, the way a delta works is the flooding of vegetated surfaces. And so it's that expansion and contraction of water across horizontally and vertically, right? So that's really the true complexity of a delta. So looking at the inundated area is probably just as important or more. So now we'll look at that. So you had a certain amount of area that's basically wet all the time, the aquatic landscape. And then you had areas that were flooded by the tides fairly frequently. Probably some variation in how much, with some places are probably flooded twice a day. Some places maybe just on the spring tides. But that's a really different landscape there. You can see the little spots that do get flooded today by high tides. And then there's the seasonal flooding associated with rainfall and snowmelt. And so that's, again, a really massive amount of area historically and much smaller today. You can see we have Yolo bypass in there. I think this is based on the 98 event. Fairly generous mapping of that. And again, fairly short term compared to the longer term in this darker blue that would have been flooded for weeks and weeks and weeks most years. So again, we can start to get a feel for that. And we can also see in the contemporary landscape where we have the pieces that are similar or remnant, such as right here at Casumnes, where we know from research by UC Davis that we actually see those functions taking effect, right? Having the expression that we would expect in terms of producing fatter fish, fatter salmon on the floodplain. You can see that we're trying to do that in very small versions of what we had. But what's more to the point, we can start to see some of the patterns that we might try to reestablish building on what we have, probably in a much smaller version, in a more managed version. But we can see that we're probably trying to bring a little bit more of these patterns in where we can. Trying to get some sense of the spatial scale and the relationship between different elements. The Casumnes research. So now continuing sort of up the elevational gradient, we can look at riparian forest. And this is an intriguing part of the ecosystem because it's often forgotten about. And just looking at these maps, made me see kind of by isolating the riparian forest, what a significant component that was of the historical delta landscape. Think of these corridors. The dark green is 500 meters wide or broader, and the light green is 100 to 500 meters wide. So these are really wide forests of riparian trees covering, in the north delta, tens of kilometers. In the south delta, still tens of kilometers, not quite as wide, but pretty extensive as well. And then also on the Casumnes-McKellamne corridor. So they're associated with large river systems putting in sediment, building natural levees. They're very spatially limited, right? This shows that they're limited strongly by the physical processes. And yet, ecologically, thinking of these as corridors through the delta for a range of bird species and mammal species, and also all the other functions they might have provided in terms of debris, lichenous debris falling into the channels, shading, et cetera, and all of the edge between riparian and marsh. So pretty big component of the system. And you can see that we do have some little pieces left at that scale, but they're, of course, much smaller. And we did this as a tricky analysis, casting transects perpendicular to the main course of the channel, which is often hard to figure out what the main course is through the delta. That's how we did that. And you can see how it breaks down. Historically, we had a decent amount, a couple hundred kilometers of fairly wide and even 100 or more of really wide riparian forest. And today we have a little bit of this, of the medium, and very little of the wider. And we can draw we can think about ecological functions. 500 is often referred to as a level that's needed for maximum ecological support of riparian corridors. And 100 meters gets you to a lot of some ecological functions, 500 for all. So you can see that taking yellow-billed cuckoo as a support, as a function, we have a lot of riparian habitat that is really not anywhere near what that species would need. We're doing really well, again, on small patches. We have some that's kind of marginal or suitable, and we have almost none that's optimal. So that corresponds with research by some yellow-billed cuckoo researchers who found that length of optimal width has decreased by 91%, similar to what we show here. So I'm going to come back to this example in a moment and think about what it means. But you can see that we have little bits, in theory, to build on. But we have kind of, you can see glimpses of patterns that might create functional units. So that was talking about these three, and like I said, we're producing it in the process of producing a report that will be released in a couple months that will give you access to all of these metrics. And then we'll be moving on to applying these through more physical processes analysis and developing conceptual operational landscape units and discussing some of the implications of those. That'll be probably in conversation with many of you in the audience and on the phone over the next year. So I'm not going to talk too much about that, except for give a little taste of it just through this example of the last metric that I showed. And we can think about the, this challenge of, if we decided that we need some 500-meter wide riparian forest, then we see, well, since you need natural levees, those are quite spatially limited where they exist and are likely to be supported. I.e. on the rivers, there are not that many places where you're going to get it back, especially if we're, unless you do the Sacramento River, there's the Cosumnes and the San Joaquin. And you can see some pieces of that already. And one of the opportunities is McCormack-Williamson Tract, so a restoration project that's it's in planning. And we did an analysis for TNC that many of you have probably seen, and I won't get into the whole study, but looking at what some of the potential was when you think at this scale. And one of the interesting opportunities at McCormack-Williamson is that it does have, if you look at the contemporary LIDAR, that natural levee still present for a decently long length. So that's an intact physical structure, and it's also on a stream, a river, that has half-decent hydrology and sediment supply compared to most of our Sierran rivers. So that jumps out as a real opportunity to restore potentially 500-meter wide riparian forest, a rare opportunity in an area where we're actually doing restoration. Now, the problem is that that is not really viable in the current project. And it's a very well thought through project, and there's just very significant constraints in terms of neighboring landowners, the need to maintain levees, et cetera, you know the challenges of doing an actual project. So this is an example of where we might yet try to look longer term and realize if we actually want that kind of feature, that this is one of the few places where we might have to try to get it. And so then you could look at it as part of a larger operational landscape unit and say, oh wow, here's where we could get the broad riparian forest, meet that metric. And then we'd be able to quantify those benefits through these metrics. So for example, in the current project, just because of constraints, there's probably not much that can be done, you're not going to get any wide riparian forest. But if you were able to fully allow that area to express itself, maybe through a longer term project, you could maybe get on the order of 2 kilometers. These are guesstimates right now. Now that would be a pretty significant increase, given that I think the existing length of 500-meter riparian forest is only 11 through the entire delta. So to get 2 in one spot, that's a pretty big difference. And this is an area where it would be connected. That's the other metric I'm not showing is there's a limitation of gaps, right? You need riparian forest with minimum size gaps. And so if you filled this area and connected a few other dots, you could potentially get a riparian forest, wide riparian forest on the order of 10 kilometers by connecting into the Cosumnes reserves. You start to see that filling the dots from here to here starts to create what might be thought of as a functional landscape for riparian forest. It's a smaller version of these bigger systems that we had. This might be one of the few places that's actually conceivable that you could get that. And you'd start to get a patch size that might actually be viable for species migrations, adaptation over time, population level dynamics that we want to set up and hopefully have succeed over time as climate changes, et cetera, et cetera. That's a little thought experiment about how we might start using these, and we'll be getting into that more in the next part of the project. So, and as you think about that, you can imagine that we'll be doing that with all the other metrics and sort of layering those on top of each other and seeing how they fit together to make functional landscapes with the array of metrics met in those areas. So with that, I will stop and open up for questions. But first, I want to thank the rest of the team at SFDI and also all the folks that we've been working with, which is much of the Delta science community. Really thank CDFW for funding the project. Danny Burmister's a great contract manager and also a scientist who's really involved in the project. Thank Carl and Dave and the science program sponsoring the talk, but also really conversations and sort of the project's been largely developed through conversations with science program folks over the years. And then we've been lucky enough to be involved in a few teams at Cache Slough, Lower Yolo, and McCormack-Williamson Tract, where we've got to explore the ideas a little bit more on the ground and bounce them back and forth. That's been really helpful. So thank you. I didn't use up all my time for once.
You have plenty of time for questions. That's great. So anybody have any questions?
Dr. Culberson.
Hey, Robin. Thanks. Nice presentation as always. And as you know, I applaud your ability to continue to teach us what I think of as a new language for restoration using new vocabulary, and it's fantastic to see what you're doing. So unfortunately, I'm always impressed with how technically capable we seem to be in approaching some of these things, at least under your leadership, but I'm a little bit more skeptical of our social constructs to try and get at these things. So a very practical question that came out of your introductory remarks, and you had sort of the description of how the groups began interacting and you know, sort of had these debates and discussions. I'm interested, if you will, in how you avoided having your conversations center around sort of the PhD du jour problem, whereas, you know, you're confronting a landscape and somebody's a newly minted PhD, and the discussion tends to focus on, well, the thing that I found that was important about the marsh was thus and such, and, you know, there are 20 such people in a room, and if you go through that, you know, exercise, you virtually never talk about the landscape scale stuff. And so I'm wondering, do you have any advice, you know, for sort of the social dynamic? It seems as though you have a team that's really hit on sort of the higher level metrics that are of importance. Can you offer advice to, you know, stakeholder groups about how best to facilitate that kind of thinking?
Well, yeah, it's a great challenge, and yeah, we all fall into it as scientists. We're interested in the things we're most interested in. But I guess we did choose the LIT very consciously and carefully to be folks who we thought were big picture thinkers, and were, you know, it doesn't necessarily matter what stage in your career you're at, I don't think, but in a position where they were willing to and interested in thinking big and maybe putting aside the day-to-day interests and research. I mean, we actually need that too, of course, because that's where expertise comes from. But the group has been really impressive at keeping an eye on the prize, and that this is an opportunity to think bigger than we usually are allowed to, and think, you know, really try to guide that at a higher level. So, I mean, they have been, you know, there's a lot of, I'm very impressed and, you know, sometimes awed by the comments that are made and taking it to another level higher rather than zooming in, things we haven't thought about in the longer run. I think, you know, your ISB here probably has, you know, some elements of that and the ability to do that. But you know, I think it's about choosing the team appropriately, keeping it small enough that it's viable and you build relationships and communication. And then also I think that the way we probably prod that, provoke that. And to some extent, I think that's half the purpose of the historical, right, is just to open your mind up to think bigger then you might think otherwise. It's not necessarily heading for that landscape, but just thinking about at that scale and about those, at that level of transformation too, because things are probably going to look really different. So I do find in all of their work that somehow inherently that change through time infuses maybe a little bit bigger scale thinking.
Robin, I was wondering if what I've found in the past when looking like at this concept of width, you know, the width you need in a riparian area, for example, is that just really isn't that much research. And it seems like it's hard. Like I was really interested in the in the cuckoo example, but it seems like a lot of times the information isn't even there that we can make those decisions about the minimum edge habitat needed or the width of an area. And I was kind of wondering if you could speak to the paucity of possibly research to actually get at some of these questions.
Yeah, I know, you're right. It's a real challenge to find that information, and we end up, you know, there is the risk of being guided by what we have data for. But, you know, part of the assignment for this team, the landscape interpretation team, is to be aware of what's available in the literature and help us draw upon, you know, what does exist, and then also what they know other researchers are working on and can be drawn from those researchers. It might not be published, but it's best professional judgment, and then their own professional judgment. So that is, we have a section in the report that we're working on that it talks about those different sources of uncertainty and, you know, how we have had to wrestle with them. You know, there's not a simple answer. You know, you can't, you know, and everybody deals with this, but, you know, we have been able to find through that combination of expertise, I think we've been able to get viable guidance, it seems, on these different metrics. So we have some basis for all of them.
Thank you. That's a very interesting talk. I really like seeing the broad landscape scale ideas, but I think one of the problems that I'm sure we're all familiar with in trying to actually employ these broad landscape ideas is like what you showed with the McCormack-Williamson Tract, saying, oh, there's this great opportunity for expanding the corridor, but political and social constraints have stopped us from actually expanding the project to the size it needs to be to make that operational unit. So did your team think at all about new approaches to bring to policymakers or landowners in terms of how to make the story more convincing and ease those constraints on actually getting big enough chunks of land?
That's a good question. Well, probably short answer is, well, yes and no. And I think explicitly that's not our explicit charge. In our proposal, it says that we're not, you know, our job. I think we define our job as not considering the economic and you know, social ramifications, but more this should be purely from the science what's needed. So this should be a scientific statement of what we would try to aim for if we were trying to accomplish these goals. And then it's in everyone else's hands to figure out what do we do with that and make those tough trade-offs between all the different competing interests. So I think that really is a step beyond what we're supposed to do. That said, you know, we're trying to operate in the applied environmental science field, and so we are trying to think about, you know, every moment, you know, how do we present this information and what are the forums that are going to be most effective, that are going to help these tools be actually used. So partly being involved in some of these local projects has been helpful to kind of test out and calibrate what we should be doing, how it might look. And then, you know, I think staying involved in these conversations about how does restoration move forward in the Delta, the conversations the Conservancy has been having about the hub and VDCP and, you know, a lot of different entities thinking about how does this move forward and how do we make those trade-offs. Also at the whole Delta scale that we're working now, it's a little harder to get into that nitty-gritty level. The McCormack-Williamson was an example of zooming in a little further where we saw the exact constraints. And I think, yeah, I can see that next steps might be zooming in more in particular areas with a more collaborative team that is thinking about the different issues of infrastructure and agriculture and actually envisioning, okay, well, how do you put those different pieces together? How the different puzzles fit together, if you will. And so that might be a next step that other people would lead.
Yeah, I really enjoyed your presentation on the 3D aspects. I'd like your opinion on what you think might be the value of exploring maybe a little more in-depth on the waterscape aspects, recognizing that, you know, the edge effect is pretty important, but depending upon what that edge is, whether it's a vertical bank or a slopey, sandy beach, and if there is even, you know, information from which to make that evaluation.
That's a neat point. Right, so the question was, could we classify, for example, edges as to different types, because those are going to have very different functions. Yeah, that's something we might think about a little bit more. Certainly, it's interesting, once you get into those riparian levees, the natural levees, you are creating a very different edge environment with those trees and undercut banks maybe than you are along the side of the Tules. So that's not something that we had, I think it might have been discussed, but it didn't make our first tier. We had too many metrics probably as it is, but something like that would not necessarily be that hard to do. And I guess, right, it's come up in terms of riprap, right? And then the question, you might ask the question, how wide does it have to be an edge? All of those things. Yeah, that, hopefully our data sets, we can add layers on them over time, right? And make them more and more fine-tuned and honed to questions. Also, as the research comes along and we realize, oh, this edge is better than this edge, and we can focus it in better over time. Thanks, good question.
Anyone else? Well, I'll follow up on I'll ask one really quickly.
Okay.
So following up on our discussion before, what's the plans to amplify this beyond the current science community and get this kind of perspective shift towards this historical function out beyond just the science community?
Right. Well, I really appreciated as we developed this concept idea with DFW, they noted that it was important to create outreach tools that would be not just designed for the science community, but would also have broader educational value and impact and sort of communicating the ideas more broadly. So in the last phase of the project, we will be creating a website, obviously, sort of de rigueur, but also visualization tools. So we actually have some artists, graphic artists on the team, both sort of hand artists and digital artists. And we're also working with an animator through kind of related project to try to start visualizing what the historical delta looked like and what it might look like in the future. Because, right, many of us find these maps really interesting and we can kind of envision what it means, the different wetland types and different species, but I realize that to the broader public, it's just a bunch of colors on a map. Doesn't necessarily mean anything. So trying to actually represent these landscapes in 3 dimensions, particularly if people are going to invest. You know, if the state's going to invest, you know, large amounts of money in these systems, they probably need to have some idea what they looked like and might look like in the future. So there is a whole dimension of that, as well as some peer-reviewed publication and technical reports. So hopefully we're trying to hit kind of the few different levels of audience through that. There was a question right here, too.
Yeah, I was just wondering, you showed a map and you had LiDAR data. Was that purchased from a commercial, or did you guys
No,
get that from?
That's the standard available DEM data set that I think Stuart Siegel was involved in putting together, maybe Chris Enright. I can't remember exactly the lineage of that. But that was fairly, we didn't invent that or buy that. That was available. But it is fascinating looking at it. This DW, right. Credit where credit is due. And but what's fascinating is that looking at that contemporary LiDAR with the historical layer, you see once you get out of the subsided central delta, you see so many of those patterns actually still intact. You see a lot of the pond, the depressions where lakes were, and you see the higher spots and lower spots. It's interesting. So the hydrology is not present, but a lot of the topography. Surprising to me, it was surprising how much that's there in that LiDAR. Yeah, Lauren.
I think you touched on this a little bit, but I was just wondering, as an output of this, are you going to have a list of it seems like you had information for the cuckoo and the black rail, but what other information would have been helpful had you had it, you know, like a list of research that we could follow up on that would help better inform this effort in the future, maybe for different kinds of species, not birds, but other.
Right. So building on that, Hildy's question earlier, what would fill those gaps? That's really interesting. Yeah, that might be something we think about in the next steps, where we talk about next steps. Yeah, that's a great point.
Anyone else? Well, thanks, Robin. That's fantastic.
Thanks.
And as you're heading out the door, the next 2 seminars on the docket, we have a new series that we're starting that's going to be, the first installment will be Thursday in this room. It's called Know the ISB. And it's going to be trying to have the ISB members give presentations about what